Hello everybody. Thank you for coming to my session. I'm Tomoya. I'm a master's student from Keio University, Japan. Today, I'd like to talk about the possibility of wireless energy as a subject useful detection. So first of all, let me explain the traditional root fall detection method. Losing volt is a dangerous phenomenon that can lead to structural damage or an accident. So manufacturing industry conducts the periodic inspection before and after application. And there are three common methods. One is direct method. This method attached strain gauge to the both directly and measure the axial force. It is a simple, so it is simple and it is not expensive, but it is less accurate compared to the other methods. And it is not suitable for online monitoring. I mean, in the case if you want to monitor the condition of the structure constantly. So the second method is harmonics. In this method, we mean harmonics like laser or photonics to the object and analyze the reflected pattern of that. This method is very accurate, but can be very expensive. You need big hardware that can handle harmonics. So the method is biosensors. This method has both good points of the other methods. I mean, it is not accurate at the very low cost, and it is suitable for online monitoring. But it needs cables that can interfere with measurement, and battery replacement of sensor is also annoying. So wireless sensing, which does not need cables as demanded, and what's more, using backscatter communication, which is used in our fiber system and can realize ultra low power communication, we can build wireless and batteryless sensors. And this is an overview of such kind of backscatter sensing system, and there are two key components. One is interrogator. It is like RFID laser lighter, and it provides range power and command and accurate continuous state to the sensor. And backscatter sensor, another one is backscatter sensor, and it is activated by the power invested by the interrogator and reflected in the continuous way to modulate sensor data. And to realize this full detection, concurrent data acquisition is essential. So we need to match flexing. We need to match flexing communication channels with different sensors. But in Gen2, it is a standard communication protocol in backscatter communication. Use TDMA method to realize multiple access. So strictly speaking, it is not concurrent communication. So we apply the principle of frequency division merge flexing to the backscatter sensing system. In this system, in this method, we assign the range of frequencies, the range of different frequencies to the different sensors, so we can communicate simultaneously. But there is still issue. What is data synchronization problem? To realize the full detection, synchronization error should be less than 100 microseconds. But in wireless communication, packet loss is inevitable. And in backscatter communication, the power consumption at the sensor is very limited. So it can only attach unstable clock, and that produces the fluctuation of time stamping and sample frequency of the sensor. So these cause the synchronization error. But these kind of errors are inevitable when you use backscatter sensor. So we develop the preprocessing at the receiving side, and this is the overview of architecture, and this is the preprocessing. And it includes outlier removal and error packet padding and clock recovery, and then we sample the data from different channels to calculate sample frequency. And another issue is the trade-off between the number of channels and the bandwidth of each channel. If the transmission rate between backscatter sensor and interrogator is below the sampling frequency of the sensor, some data sample will be lost, and the range of frequency response can be analyzed is limited. So in our system, we use this packet, and we collect 3-axis acceleration will be 180 packets per second. And when the bandwidth is, what it is like, when the bandwidth is not enough, for example, like your BPS, transmission rate will be 144 packets per second. It means you can send only 144 packets. You can send only 144 point of data in a second. And if the frequency of if the sampling frequency of the sensor is like 200 hertz, which is actually 1 kilometer, transmission rate is not enough to the sampling frequency to sampling rate. So some sample will be lost. Then, so to prevent this, we need to allocate enough bandwidth to these channels. And to evaluate whether Backscatter sensing is possible with the same accuracy of wireless sensors, we developed experimental system. And this is a structure which is connected by 2 bolts, and they are 2 wired sensors and 2 Backscatter sensors are attached. And wired sensors are connected to the device. And wireless communication channel between Backscatter sensor and the interrogator is constructed when the interrogator provides power. Then analyzer adds excitation to the structure, and the sensor sends acceleration data to the device and interrogator, and they send data to analyzer. And the analyzer calculates damage index, which is the metric to quantify how much the volts are used. Then compare the results from Backscatter sensor with wireless sensors. And these are one cycle experiment, and we perform the same procedure after changing the looseness of the bolt with the full image. And then we explain the damage index. In this research, we calculate damage index from transmittance function. Transmittance function is a variable model analysis, which interferes the transfer function of the structure from excitation and response from data. But in transmittance function, we need just response point of data. And we need just different response point of data. So it quantifies the correlation between the sensors. So if the bolts are tightly connected, the different part of the structure moves in phase. But when the bolts are loose, the different parts move differently. So there is weak correlation. So and then we calculate damage index, and this is very simple. This definition is how different between baseline state and observation state. So we set the condition where the bolts are tightly connected, that's baseline state. Then use the bolts. And this is our experimental setup, and these aluminum bars are connected by 2 bolts, and this is our Backscatter sensor, and they are attached here, and our sensors are attached here. And these black plates are antennas, and this compact shaker adds excitation to the bolts. So let's talk about evaluation. This shows the Fourier transformation of data from wired sensors and wired sensors. And the normal line shows the result of wired sensors, and dot line shows the wired sensors. And the blue line shows the baseline state where the bolts are tightly connected, and orange line shows the observation state. And you can see the result is not exactly the same, but the peaks are the same location. But the peaks are at the same location. So, for example, in baseline state here, and here, and here, and observation state here, and here, and here. So we can say important frequency characteristics are in the plane. So let's calculate transmittance function. We compare wired data and wired standard, and there is almost a result, especially in low frequency, in this case 100 hertz. But this pattern will fade away when the bandwidth is narrow. In this case, we compare 2 wireless channels. One is wide bandwidth channel, which is 10,000 10 kbps, and is the same result we could use result. This one. This one. So it agree well with the result. But when the bandwidth is not enough, this one will be away. So these are the results for 200 Bps channel with which transmission rate is low sampling frequency of sensor. It is natural, but it is important to consider the construction of the network because especially between the number of channels and the transmission rate of each channels. And the last one is damage index result. And the blue bar shows the blue bar shows the baseline state and of wire sensors and wire sensors. It's all the same. And when the bolts are loose in this experiment, 0 newton meter, this value increases. Okay, but the change is much more sharper in wireless case, and we think is caused by increased target error rate. But loose ball detection can be still possible if we set some threshold like 0.4. So, conclusion, we verify the possibility of Backscatter sensing. We verify whether Backscatter sensing is possible with the same accuracy of wireless sensors. And it's possible if you processing to restore the data synchronicity. But however, sufficient bandwidth allocation is also necessary. That's it. Thank you for listening.